All right, can you scroll down a little bit, Ken, on that? Oh, we lost him. It was a really cool pie chart that I wanted to pull up that we can talk a little bit more about. I'm sure he'll pop up when he can.
Looks like it's coming up there. So I can explain what I did here while he's bringing that up.
Yeah, perfect.
I had attended several years, attended and spoken at the NC State Vermiculture Conference, which is no longer in existence because the lady, Rhonda Sherman, who had run it, retired. But there I met Dr. Zach Jones, who's a young PhD who has this vermimicrobiome project. He's doing DNA sequencing. He lives in Colorado. He's doing DNA sequencing specifically on vermicompost. So he's been having people over the past several years, not as much in the past few months, but over the past several years, having like whoever, like, hey, send me your vermicompost just to get it sequenced so that he could have all this data to compare. He had asked me if I'd send in a sample, and what we did was he sent me three of these little vials, and then I can't remember what this liquid is called, but it basically locks the biology in place. So I had a vermicompost sample that I put in the vial, and then I put this liquid in there, and it locks the biology right where it's at right then. So like no addition, no subtraction of any biology. So we did that with vermicompost. And then I took that exact same vermicompost and I used the recipe that I put out through my podcast and things like that, and brewed a 5-gallon brew with fish hydrolysate, humic acid, and water at ambient temperature. Brewed that for, I think it was 24 hours for testing purposes. And then I put that in a vial and I locked the biology in place. And then I did a compost extract. So a compost extract, for people who may not know, is where you're making similar to a compost tea. You're putting solid compost in water, but instead of adding foods to try and get those microorganisms to reproduce, you're just putting it in there, extracting microorganisms, and then taking it out and using it. So we had a vermicompost sample, we had a compost tea sample, and then third, we had an extract sample where I just took ambient water, put the same exact amount of vermicast in there as I used for the tea, which I believe was 3 cups per 5 gallons, and then mixed it up by hand for 5 minutes, put that in the vial, locked it into place, and then Zach did DNA sequencing. He found that my vermicompost, he called it the gold standard. It had the most diversity of any that he had seen. And then when he was looking at the extract, so what I was explaining to you all, and if you may not have as much experience, I just want to make sure you're clear on this. The extract is where we're taking water, we're taking compost and putting it into the water, and only for like 5 minutes, maybe aerating it or mixing it by hand, and then taking that and spraying it out on soils or plants. So that's an extract. A compost tea is where you're putting compost in there like that. You're adding little bits of foods for microorganisms, agitating it, aerating it for 12 to 48 hours, and trying to get an explosion of microorganisms. So with the vermicompost, we had, tons of diversity. And then when we made the extract, we've got just the water and the organisms. And so there was great diversity within the extract. It was pretty much showed the same species and levels or numbers as we saw in the vermicompost. And then with the vermicompost tea that I made, which is getting agitated and brewed, I'm trying to get to peak populations of microorganisms. And what happened was he has a count of, it's either 1 or 2, and I know it's 1 for sure, that's like the majority of, there's one species of bacteria that just like takes off where everything else kind of fizzles off and either goes away or is in very low numbers. So, that bacteria is a growth promoting bacteria, which is going to be good. But if you're looking for diversity, you're losing that diversity by brewing, whereas you're keeping that diversity by having an extract.
And that goes back to the hydrolysate was the limiter. And was it a rhizobacter was the species that or was it the Pseudomonas that came through?
It's been a while since I looked through that information. It was one of those two, and I honestly don't remember.
Yeah, no worries, no worries. But it proves a very interesting point about, you know, what your goals are when you're doing this type of work. And if your goal is purely to, you know, increase plant health, then yeah, adding the fish hydrolysate is a good tool. But again, if you're looking for diversity, which I think is probably more important, then it's a limiting factor when you start adding foods. And I know Elaine promotes like a lot of different recipes for different things. Personally, I've always been like, okay, I'm going to make my extract or my tea. And then when I go to apply it, then I'll add those food sources so that I don't limit that population or that diversity, but I still get the benefits of getting those food sources out into the field. Is that a similar practice that you do, or is it more you tend to add those foods in prior to completing the brew or the extract?
No, yeah, I do a similar practice where, so I had been brewing up until I got this information from Zach. I had been more applying compost teas when I was going out as my business to clients. I was doing more compost teas, but I would also add, so I would brew compost tea, 30 gallons. I would put that 30 gallons into 250 gallons to carry it and act as my dog is squealing. I'm about to fucking lose it on him. So yeah, 30 gallons into 250 gallons. And so within that 30 gallons, I'm using a little less than half a cup per stuff of foods. But then once I'm putting it into the 250 gallons, I'm putting like a cup of fish hydrolysate into that 250 gallons and a cup of humic acid into that 250 gallons.